Three-line charts can also be used when we have a graph of the second derivative. So in this case, we have a graph of g double prime here, and we want to know something about g of x. So we're going to do the same thing. We are going to record what we know about g double prime of x. We're going to translate that over into something about g of x. And we know that we have concave up, concave down, increasing, decreasing, plus, minus. Those are all things we can read from the graph. However, when we look over at this, if we have this level, there's only actually one level of f double prime or g double prime that translates over into the original function. So when we go to do this translation, these two aren't actually going to be very useful because this is the only translation that we really have. So while you're welcome to go and fill in the concave up, concave down, and increasing, decreasing levels if you like, there's no real need to. We're really just interested in this. Right here, positives and negatives. So I see here at -2, so this is above the x-axis until -2, and then it's above the x-axis again until 1, and then below the x-axis until 3, and then above again. So I'm going to translate over. Okay. If you think back to our last lesson also, it's entirely okay if you know what you need to just fill in that line when you're doing your translations. Alrighty, so if we look at here, an inflection point occurs when concavity changes sign. So looking over here, there's something to be very careful with. Here concavity changes sign, here concavity changes sign. There is no inflection point because concavity does not change. It's very tempting for people to say, oh, okay, a g double prime of x is 0 at -2, -1, and 3. Therefore, all of those are inflection points. No, 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 no. An inflection point occurs when concavity for g of x changes from concave up to concave down or vice versa. So that we're looking for where g double prime of x changes sign. So positive to positive, not an inflection point. So our answer then is that g of x has inflection points here and here. Oops, this is a positive one, isn't it? Not a negative one. My bad. That's also g of x. Okay. And from here, we can be asked any question about concavity of g of x. So we could also just be asked, let's say, for what values of x is g of x concave down? And looking right here, we can see that g of x is concave down when x is between 1 and 3 because g double prime of x is negative. Oops, helps if you can see that. Okay, so same ideas that we did with first derivative graphs. It's just we're translating from here to here instead of from here to here. There are also other ways that this kind of question can be asked without numbers necessarily. So let's say right here, Okay, so second derivative, f double prime of x. Let's sketch that. That should be touching right there. Okay, so this is a graph of f double prime of x versus x. Still can't see that very well. Give me just a second. There we go. That's clearer. But this is all the information we have. There are no numbers. Notice, however, what we're being asked. We're asked how many inflection points. So we're not asked for the specific values of it, just to count the number that there are. So we still have enough information to do this. Be careful though, inflection points occur only when concavity changes for f of x. So let's do our translation charts, and again we don't need these top two because we don't have a translation for them to f of x. And also we kind of don't know what these numbers are, but that's okay. I mean, we can see that this is clearly below the x-axis, and then it switches to being above. Then there's another 0, and then it's still above. And then there's a 0 and it's below. And then there's a 0 and it's below. And there's a 0 and it's above again. So that's still enough information for us to translate to f of x. So that's going to be concave down for a bit, concave up, concave up, concave down, concave down, concave up. So we're looking for the inflection points, the points where the concavity of f of x changes. So there's a change right there, a change right there, and a change right there. Notice that these are not inflection points. So that means to answer our question, f of x has 1, 2, 3. And how do we get that? Because f double prime of x changed sign 3 times, so f of x changed concavity 3 times. And there we go.